Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, Dynamic Observability, the Quest for Real-Time Data in Cloud-Native Application, brought to you by Rookout. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to access the recording for on-demand viewing. We will be sending out a link to access the webinar on demand, or you can visit devops.com/webinar, and it will be available for you as well. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion by using the chat tab, so let us know your thoughts or just say a quick hello. Finally, stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards, so stay tuned to see if you're a winner. Joining me today is Oded Corrett, VP of Product, Rookout, and Sharon Schechner-Charlin, Director of Production Marketing, also at Rookout. And with that, I'm going to put myself on mute, turn off my camera, and let you begin.
Great, thank you. Thank you, guys. Thank you for joining us. My name is Oded. This is my colleague Sharon, and we are here to discuss dynamic observability with you.
All right. So indeed, it's very exciting to be here with you, Oded, and with the audience at home. My name is Sharon Chanlin, and I'm Rookout's Director of Product Marketing. And as you can see, we're trying to make fun and not take things too seriously. So feel free to ask questions wherever in the end of the session. All right. Before starting our quest about real-time data and dynamic observability, let's take a step back. Let's see where we are today. So adoption of microservices, containers, dynamic orchestration, and DevOps technology is in general adopting cloud-native application and infrastructure. And we see that this trend is going to lead us to 2024. 70% of all applications going to be cloud-native application. So we've spoken to our customers, and apparently together with this adoption, we see some great big challenges. And one of them is obviously optimizing cost. Others are modernizing monolithic application. We need to modernize them into microservices, rebuild them, and obviously to adopt new tools and methodologies to support the entire new ecosystem. So having all those efforts around engineering power and with money, obviously, we still find ourselves worried about some glitches, some outages that are going to take place, just like the Facebook outage that just happened a few weeks ago. So we see ourselves striving and looking more and more into observability. This is the one thing that can help us in this kind of situation to understand what's going on inside our code, what's going on to our application. So observability adoption. The state of observability, the latest report from VMware 2021, we see that a third of companies already using or implementing observability solutions, which is not surprising. And another third is thinking of implementing it. Observability pipeline in the next coming 6 to 12 months. So what do you think of that? Those numbers are surprising? No, not at all. It's not surprising because cloud-native applications are super complex and super dynamic, and this is why it's actually pretty trivial to see those numbers. And in the end of the day, the only way to know what's really going on in the code, what's really going on in the application, is to get traces, logs, and metrics, and even better, to visualize them in a way that immediately helps you understand what's going on inside the code. Further seeing the phenomena, the extent of the investment We see another quote from Gartner. Gartner is naming 2021 the year of observability. They also emphasize the fact that observability is not the traditional type of monitoring. It's another step. It's taking another step furthermore, and we're going to talk about it. So observability. Observability is in the title of this slide, and it's in the title of the webinar. And I said the word observability like 20 times so far, and maybe 20 times more in the coming few slides. So before we continue, I want to make sure that we really understand what observability is, and maybe Oded can help us with that.
Sure thing. I actually have a couple of slides. I'm glad that you asked.
That you asked.
Sure. As you mentioned, observability means going beyond monitoring, going beyond looking at the application from outside. Observability is about being able to always see what's going on inside the code, inside the application. I'm going to use the word traditionally, although, as you said, observability is the upcoming new trend, and yet traditionally in the world of the observability, we speak about three main pillars. We speak about tracing, which is understanding the thread and understanding the microservices, understanding what happened before and what happened after. We speak about logs, which is print out from the code telling us that something specific happened or that a certain service has performed a certain action. And we speak about metrics. We speak about aggregating data, aggregating numbers that measures a quantitative amount of something specific happened, a specific issue happening, a specific service being requested. And as we see in this slide, we are already familiar with a big number of vendors. We just measured a few of our favorites here. There's a very popular tracing vendors, some very popular logging vendors, some very popular metrics vendors, and almost every customer that we speak to, and definitely all of the attendees in this webinar, probably use at least one of them. Usually companies use a mix of those, which they connect into what we call the observability pipeline, a system that collects all of these types of data, presents them to the engineer, and helps them make insight-based decisions and results. But
there's always a but.
But there is always a but, and if there wasn't a challenge, we wouldn't have a reason for a webinar. These tools still have their limitations or their challenges. We speak to many customers at Rookout, and really the one thing that always comes up in a conversation about observability is the challenge of context, of knowing that an issue happened and not understanding what happened just a minute before, what was significant in the set of data that was going on in the environment that may have caused the incident to happen. If you're speaking about cloud native applications, about complex and dynamic microservices-based applications, you look at a problem in one pod or in one Lambda function, but in order to understand what caused it, you have to understand what was going on in every other single pod or Lambda function. Understanding the context here is always a challenge, and our customers invest a lot of time and engineering and effort and money in adding that context on top of the existing observability pipeline. But adding more context is very often quite expensive.
So yeah, you're probably very right. The number one challenge is context, a lack of context. And when we don't have enough context, what do? We just go and print another log line. But printing another log line is not ending with that. It's waiting, deploying, and in the end of the day, all this cycle costs money in different ways. And that leads me to another challenge, big challenge around observability. And this is the fact that the costs are just booming. Whenever there is a log line that we're missing or a data point that is nowhere to be found, then we go back, we write code, and then we wait for the next deployment. Eventually we get the data, but this cycle is really time consuming, and all those logs that we want to save in advance to make sure that we have them later obviously needs to be saved somewhere. So we need to pay everything we need to pay. We need to pay for the cloud service provider to keep it for us. We even pay with performance because every log line that we print is actually slowing down our application. So there's pain all over, and we are not really satisfied. And why is that? So this is a very strange phenomenon. It's a paradoxical phenomenon. On the left-hand side, we see that average annual cost of limiting log data is accumulating to a loss of $3.4 billion. And why is that? It's because of the fact that whenever there's a bug and we look for its root cause, then we go and reproduce this problem in staging. And in order to do that, we need to make sure that we have the setup in advance, and this on setup obviously costs money. If we didn't find the root cause and resolution is not there, then obviously we're not meeting SLA, and we're jeopardizing our customer experience, and we lose credibility. And sometimes in some industries, we even lose transaction. We lose cash. So it's all accumulates to a very, very big number. So this is happening on the left side. On the right-hand side, we see the other way of the equation. This time, we're losing around $1.8 billion. Average annual cost of collecting log data that is not being used. So we're keeping logs, we're making sure that they are available, but we don't need them in the end of the day. So what happened there? It's a classic login FOMO, fear of missing out. We want to make sure that if we have a production bug that we are afraid of dropping the service, we want this log to be there for us, and we make sure and we push inside our organization that log verbosity will be high as possible, and those logs, they just accumulate into a very high volume and obviously to a very high price. So again, payment all around, and still we're not satisfied because we're losing here, we're losing there, and we don't have context. So still, we're in a problem here.
Yes, definitely. And the third challenge that we see in the current ecosystem of observability, it all boils down to classic observability is like looking at a black box. It's like you get the metrics, you get the log lines, you know what is reported to the outside world, but you cannot see what's going on inside. You cannot see the stack trace. You cannot see the actual variables in the code as the developer who wrote the application of the service wrote it. And taking that one step further, as you have already mentioned, exporting additional data, exporting additional metrics, poking additional holes into the box that will allow me to see what's going on under the hood is expensive. It means adding more code. It means waiting for a rollout. It means spending more engineering hours and more business days before the issue can be resolved. So just to recap, we've mentioned that cloud native is hard and that we need observability to overcome it. But we also mentioned that current observability tools do have their challenges. And when we try to really pinpoint these challenges and to look at what's missing in the current observability ecosystem, we see that the traditional tools were just not built for cloud debugging or for production debugging. Developers are used to using things like command line debugging or local debugging and working locally on their desktop, but that is just not something that you can use in our remote environment. And from the right-hand side, some engineers do know how to do remote debugging, but it does not scale and it does not work with hundreds or thousands of microservices. And some teams fall back to the ancient practice of crossing fingers, deploying to production and hoping that it will somehow fix the problem. But most of the industry has already accepted that logging and tracing are the best we can do at the moment. And in many situations, it is good enough. But we believe that we can do better, or as we like to say to each other, ain't nobody got time for this.
Ain't nobody got time for that.
So we need to accept the quest. We need to take the challenge, and we need to find a new, better way of achieving real-time observability, of having instant access to the data, of being able to immediately pinpoint and understand what's going on in our application. And for that, we need the ability to fetch new data in real time.
All right. Very interesting. Let's see how it goes. So in traditional observability, I used to ask questions, look for new data that is missing for me, but I wouldn't really get answers on the fly because I had to write more code and wait for that deployment. And as you said, ain't nobody got time for that, right? So this is the traditional observability. What's going on the dynamic observability? Now I ask questions, and surprisingly enough, I can get real-time answer. I can actually get the data that I need on the fly. So how do I do that? It is done by dynamic instrumentation through bytecode manipulation that allow any engineer to fetch real-time data from its code and get to the root cause faster. As we can see in this little animation, we set a non-breaking breakpoint that will not stop your application. And no matter where you are and how is your application is built, and I don't care what language do you use, it's really agnostic to that. And immediately I get the data that I need. I can get my traces log, I can get a debug snapshot. And while having that, I can pipeline it to whatever observability tool that I have. And this is truly powerful. I don't need to wait anymore. I don't need to shift my engineering power to something else because we're designed to build code and not to fix bugs and solving issues. Yes, obviously it's part of the job, but we wish to do it in a shorter manner and be more efficient. And obviously happier because we like things to be more simple.
Yeah, the way you described that made me think of the black box problem again, because again, in traditional monitoring, we would look at the system from the outside and try to understand what the signals mean. But you just showed us that you can set what looks and feels like a breakpoint. You actually look at the code, and the actual data that you fetch instantly is the actual state of the application, the variables, the stack trace, all of the context, all of the information that a developer who wrote the program would expect to see. So in a sense, what we are doing here is bridging the gap between the dev on the right-hand side who can see inside the code, who know what is going on, but do not always have access to the production environment or to the observability pipeline. And on the left-hand side, to the ops team, who usually look at metrics from the outside, but do not have access to the code, do not have the ability to change the code. And what we are actually doing is helping both of these teams work closer together, communicate much more smoothly, and solve problems faster, which is the bottom line, what we are trying to achieve here at Rookout. And what have we seen? We've seen a new technology and a new step for the world of observability. And the concept of dynamic observability, the concept of being able to fetch new data in real time, lets us get context instantly, which is always crucial in solving problems. It means fixing bugs quicker and keeping our customers happy because there is less downtime, because there are less failing transactions. It means that since we are not busy fixing bugs, we have more free time to develop new features, to provide more value to our customers and to enhance our business, and to drink coffee, because that's what we love doing as engineers. It means that we don't need to print everything to log in advance because maybe we will need it, which will reduce our logging cost. It will reduce the performance impact of our logs. And bottom line, and you said that, and I completely agree, it means we have happier developers, and we invest so much in having the right coffee machine and having a foosball table and having all the right best swag in the office. Having engineers who need to spend less time debugging is guaranteed to generate happier developers and happier engineers and to have a more productive team.
Happiness all over.
Yeah, what more can you ask for? That's what we had to share. We would love to hear some questions from you. And of course, you're welcome to try Rookout on for yourself or have a chat with us. Just drop us a line.
Absolutely. Yes, we do have some questions, but I did want to remind the audience that if you'd like to submit a question, just head on over to the Q&A tab and we'll get to it. First question, what's the difference between Rookout and Dynatrace?
Very good question. Dynatrace was not sure if it was in the traditional observability tools. It's one of the, I like to call it a classic APN, although it is a rather new product. It is a tool made for operations teams. It is a tool made for monitoring the environment as it runs in production. It is a very powerful tool. It provides all the metrics you can think of, and it provides all of the deep tracing and root cause analysis capabilities that an engineer could want. But it does that in the traditional observability way, which means that if there is something you did not think about measuring in advance, you will need to write code to achieve it. You will need to wait. I will also mention that Rookout integrates with all of these popular observability tools, and Dynatrace is one of them. So any new data, any new log line, any new metric that you collect with Rookout, you can pipeline it to Dynatrace, to AppDynamics, to Datadog, whatever your favorite existing observability tool is.
Excellent. Next question, what use cases will be suitable for Rookout?
I think that the classic one will be production debugging, because this is a very challenged situation. As Oded showed, we have those boxes that we don't really know what's going on inside. This is the main problem with production. We don't have access. VP engineers usually spend a big chunk of their time just granting access to their engineers to debug. So production debugging is definitely one of the main use cases. But the solution is valid for staging and for dev environment. It doesn't really matter, because in the end of the day, everybody needs real-time data. So in production, it's classic, but real-time data is also needed in any other environment. So the solution actually suits all.
Oh, great. Next question, what technologies do you support?
Rookout currently has an SDK for Java, Node.js, Python, .NET, Ruby, and we just recently released a new SDK for the Go language. And when I say Java, it's all of the underlying JVM-based languages. When I say .NET, it's all of the C# and every most dynamic Microsoft languages. So we try to have a full coverage of technologies, and we currently constantly expand our tech coverage based on customer requests.
Okay. Next question. Do you streamline to other observability tools or have integrations with them?
Yeah, I'm guessing this question was asked before we mentioned that we pipeline it to the APM tools. But yes, I will use this excuse to mention that it's not just APM tools that we pipeline to. We pipeline to most commonly used logging tools like Logs.io and Sumologics and Coralogics and a few other friends in the domain. And definitely to other monitoring visualization tools. We also have integrations with collaboration tools. Here at Rookout, we actually use Rookout in a way that whenever something happens, Rookout will send a snapshot to Slack, because most of the engineering team uses Slack on a daily basis. So you can actually, in a way, use Rookout to monitor for issues and collaborate by sharing data via Slack, Jira, Teams, and any other tool that your team is using currently for collaboration. You are muted.
Julio?
Oh, yep. Sorry about that. Next question is, does Rookout save the data?
So the Rookout default configuration is SAS-based, and Rookout only maintains the data for a small number of hours. We work with many customers who handle sensitive data, medical technology companies, banking companies, fintech, CRM. We have a lot of customers where the business data is very sensitive, but the fact that we only keep it for a few hours helps the security and data privacy teams at those companies give us the green light. It also helps us save on storage costs, but that's one of our concerns now.
Okay, next question. Do you have an on-prem offering?
Yeah, we have what we call a data on-prem offering at Rookout, which means that managing the agents, managing the deployed SDKs, and providing a pleasant web experience is still something that is managed by our SaaS offering. But we also have an option in which the data doesn't even leave the organization. So we provide a local data store deployment and the data controller deployment that are fully within the customer's environment, and only required telemetry information is broadcast outside.
Okay, great. And another question here. I'm a .NET guy, so what would we need to do to our code to incorporate this?
Rookout in every language has a very easy to deploy agent. It's usually one line of code. In Node.js, it would be an import, or in other languages, it would be an include. For .NET, we have a simple NuGet package that you can include in your code. Just add it once when your application starts, and Rookout is good to go and ready to deploy in every single one of your services.
Excellent. So far, that's all the questions we have. If you have any questions, do submit them right now. For now, I do want to remind everybody that today's webinar has been recorded. So if you missed any or all of the webinar, you'll be able to watch it again. We will be sending an email with a link to access the webinar on demand, and it will also be available on devops.com. Just look in the on-demand section in the webinars page, and it should be there. I suppose I'll also announce the $425 Amazon gift card winners. Our first winner is Tim P. Congratulations, Tim. Our second winner is Chris H. Our third winner is Yuri M. Congratulations, Yuri. And our final winner is Tan M. So congratulations to all our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, check your spam folder. Okay, still not seeing any questions. We'll do a last call for questions here. Going once. Going twice. Okay, great. Well, Oded and Sharon, thank you very much for taking the time to put this presentation together.
Thank you, Julio.
Of course. And I'd also like to thank the audience for their time and engagement. This is Julio Godinez signing off until next time. Be well.
Thank
See
you.
you guys. Take care.